يعطيكم العافية. Today I will talk about the seminal fluid analysis or semen analysis. And the aim of this test is to assess the male fertility. Also, we need this test in case of rape. في حالات الاغتصاب ممكن أنا بحتاج هذا التست. Now, what is the semen? Semen composed of two parts. The first part, which is the spermatozoa that come from testis, وهي عبارة عن 5%, and second part, which is 95%, which we called it seminal plasma. And seminal plasma here, the main function of seminal plasma here, this seminal plasma will provide the nutrition for spermatozoa. Also, it is an osmotic protective solution with high osmotic pressure to keep the cell wall divisions, which are spermatozoa, in their stability state. Also, seminal plasma will activate the spermatozoa motility. So again, seminal fluid composed of two parts. 5% of this fluid is a spermatozoa that comes from testis, and 95% which is seminal plasma that come from different source. First source, which is first location, come from different location. The first location اللي هو seminal vesicle. So seminal plasma will come from different location. The first location اللي هو seminal vesicle. The seminal vesicle, this location will provide viscous fluid, and the pH of this fluid is neutral to slightly alkaline, yellowish in color. It will provide 60% of this fluid. This fluid that comes from seminal vesicle will contain flavine and also contain fructose. And the flavine, when exposed to UV light, it will produce fluorescent yellow. عشان هيك في حالات الريب الاغتصاب لما يعرفوا انه هذا جسم مثلا الضحية وين السيمينال فلويد عليه على جسمه او على ملابسه، ممكن يعرضوا اللي هو الملابس او جسم الضحية لليو في لايت. مجرد ما شافوا فلوريسنت يلو بيعرفوا انه هون عينة السيمينال فلويد، لانه الفلافين مجرد ما تعرض لليو في لايت بيعطي فلوريسنت يلو. Also, a seminal vesicle will provide fructose, and the fructose is very important source for energy. Now, second part that produce seminal plasma, which is the prostate, and the prostate always here will produce milky fluid, and the pH of this fluid is acid, approximately 6.5. This prostate produce a fluid that contains citric acid, and the citric acid here act as anticoagulant. Also, produce a proteolytic enzyme, and this enzyme responsible for coagulation and liquefaction. So this fluid that comes from a prostate will contain citric acid as anticoagulant, a proteolytic enzyme that is responsible for coagulation and liquefaction. Also will produce acid phosphate, and acid phosphate here is act as buffer. A third part that produce seminal plasma or the fluid of seminal plasma اللي هو epididymis gland. والepididymis gland عادة provide 10 up to 15% of the fluid. This fluid provide or contain a nutrient help the spermatozoa to move. تقريبا هذا اللي هو شو هو السمن، من وين اجا، شو هو. عبارة عن زي ما حكينا سبرماتوزوا 5% بتشكل هاي السبرماتوزوا بتيجي من التستس، و95% هاي بنسميها اللي هي السيمينال بلازما. هاي السيمينال بلازما زي ما حكينا بتيجي من السيمينال فيزيكل، والسيمينال فيزيكل عادة الفلويد هذا بيكون فيه الفلافين وبيكون فيه الفركتوز. وفي كمان السيمينال بلازما بيجي من البروستات. البروستات زي ما حكينا بوفر اللي هو الستريك اسيد، وبوفر كمان اللي هو البروتيليتيك انزيم، وبوفر كمان اللي هو الاسيد فوسفات الاكت از بفر. وعندك السورس الثالث اللي بوفر أو اللي بزود السيمينال بلازما اللي هو الإبيديدرمس جلاند. هذا بالنسبة للسمن أو introduction عن السيمينال fluid analysis. Now I will talk about the collection of seminal fluid analysis, and the collection here should be done by using a sterile wide mouth container provided by the lab, and this container should be sterile, should be wide mouth container with a screw cap. Why wide mouth? Because to make the collection very easy, because always to analyze the seminal fluid we need a complete sample. Incomplete sample always should not be analyzed, particularly if the first portion of the sample is lost. عادة incomplete sample أنا ما بشتغلها، عشان هيك أنا بوفر للبيشنت wide mouth container مشان ما يصير فقد للعينة أو ما جزء بينكب منها. هلا الsample should be collected after a minimum of 72 hours and no longer than 7 days of sexual abstinence. What I mean by sexual abstinence? Sexual abstinence اللي هي no sexual activity، يعني بيمتنع الشخص عن ممارسة الجنس أو sexual activity minimum 3 أيام maximum 7 أيام. هلا ال ideal sample should be collected in the privacy room near the lab. Otherwise, if there is or if not collect in the lab, otherwise the sample should be delivered to the lab within 1 hour after collection. But it's recommend to collect the sample in the lab in the privacy room, because the time of collection is very important to know the liquefaction time or to know the period of liquefaction. هلا رح نحكي عن الليكويد او اللي هو البيريود اوف liquefaction لقدام رح نعرف شو هي. فعشان هيك السامبل ideal sample should be collected in the privacy room near the lab. هلا السامبل should be labeled. Sample or sample container should be labeled with the name of patient, period of abstinence, date of collection, and time of collection. Time is very important here. For initial evaluation, we need 2 samples, and the interval of time between the samples should not be less than 7 days and more than 3 months apart. يعني إذا الشخص بده يعمل السيمينال فلويد أناليسيز لأول مرة بحياته بحتاج منه عينتين. الفرق بين العينة الأولى والعينة الثانية لازم ما يكون أقل من 7 أيام ولا أكثر من 3 أشهر. هلا sample should be obtained by master patient and ejaculated into a clean wide mouth plastic container, and this sample should be warm to minimize the risk of cold shock with temperature not less than 20 and not more than 40. إذا السامبل عادة بياخذوها بطريقة بسموها الماستر بيشنت. الماستر بيشنت means الاستمناء by using the hand to ejaculate the sample in the sterile container. هلا incomplete sample should not be analyzed, particularly if the first portion of ejaculation is lost. Why the first portion? Because always the first portion of ejaculation is loaded with high number. The first portion of ejaculation is always loaded with high number of sperm. So when you lose this first portion, your count not correct. For that, incomplete sample should not be analyzed. وهي نقطة كثير مهمة، إنه أي عينة بتحس إنه نكب منها لازم ما أشتغلها. لا خاصة بقول لك إذا الجزء الأول من الإيجاكيليشن انكب المفروض ما أشتغل العينة. ليش؟ لأنه دائما ال first portion of ejaculation loaded with high number of sperm.
Here in this slide I will talk about the semen analysis or examination of seminal fluid in the lab. And examination of seminal fluid or semen analysis, we need to look for the macroscopic examination, which is done with naked eye, and also we need to look for the microscopic examination, which is done under microscope. In this slide, I will explain the macroscopic examination of the seminal fluid sample. First, we need to look for the volume of ejaculation, the normal volume of seminal fluid analysis that ejaculated from the person. Normally, الفوليوم ejaculation between 2 up to 5 ml. يعني الشخص الطبيعي عادة بيعطي عينة من 2 لغاية 5 ml. The color and appearance of normal seminal fluid is milky whitish, while viscosity is viscous or consistency viscous. Liquefaction time عادة السمن is a thick gel at the time of ejaculation and normally become liquid within 10 up to 30 minutes after ejaculation. Now, liquefaction time is a measure of the time it takes for the semen to become liquid. خلينا أعيد لكم إياها بالعربي. يعني liquefaction time أنت لما تجيك العينة على اللاب بتكون جل، لأنه بعد ما يصير ejaculation لهاي العينة من الشخص، يعني الايجاكوليشن اللي هو القذف، بتكون العينة على شكل جل. قديش بدها وقت حتى تتحول من جل لليكويد تصبح ليكويد؟ هذا مسميه اللي هو liquefaction time. قديش التايم اللي أخذته حتى تحولت من جل لليكويد بنسميها اللي هو liquefaction time. normally لازم العينة تتحول من جل لليكويد ما بين 10 ل 30 دقيقة. شو كمان لازم نحكي عن الماكروسكوبيك examination؟ ممكن نقيس ال pH of seminal fluid. وال pH of seminal fluid, you can use the pH strip, you can moist it by the seminal fluid sample, and you can measure the pH. And normal pH of seminal fluid between 7.2 up to 7.6. We can say slightly alkaline. In this slide, I will talk about the second part of seminal fluid analysis or semen analysis, which is the microscopic examination. And remember that microscopic examination always done after complete liquefaction, when the sample become liquid. In microscopic examination here, we need to know if the sample contain sperm or not contain. So we can say present of a spermatozoa. How can check if the sample contains sperm or not contain? By doing the wet mount preparation. And wet mount preparation here is very easy to perform that, and all of you know how to prepare the wet mount preparation. First step, we need to be sure that the sample is liquid. After that, you can mix the sample 5 to 10 times to make it homogeneous. After that, you can take 1 drop of this seminal fluid and place it in the center of a clean slide. Then you can take a clean cover slip and cover the drop of seminal fluid to make the wet mount. Be careful here. Don't press the cover slip by your finger. Don't use your finger to press the cover slip. Why? Because you will affect the motility of the sperm. The presence of spermatozoa or wet mount preparation here is very important to evaluate the motility. Now suppose that you prepare the slide, the wet mount preparation, and now we need to examine this slide under a bright field microscope by using low power and high power X or high power lens. What we need to see here to search for sperm. Suppose that you examine all wet mount preparation slides under microscope and there is no sperm under microscope. يعني احنا فحصنا كل السلايد، اوكي، كل الفيلدز ما في عندي sperm. In this case we need to concentrate the sample to know that the sample contains sperm or not contains sperm. For that, if there is no sperm present in your slide in different fields, we need to concentrate the sample. How can concentrate the sample? By taking the sample, the container of sample, mixing again 5 to 10 times by inversion. Then you can take, for example, 10 ml of this fluid. You can take كلهن أصلا ما بيجنش 2 ل 5 ml من الفلويد. You need to take the fluid, okay, and put it in conical tube. Then you can centrifuge the sample at 2000 rpm for 5 minutes. After that, you can remove the supernatant and you can take 1 drop of the sediments, because this sediment is concentrate. If the sperm is present, you will see it, or you will find it in the sediment. So I will take 1 drop from the sediment, place it again on the center of a clean slide, cover it with cover slip, don't press the cover slip, and you can examine the slide under microscope again. I will examine 10 fields. If there is no sperm present in your wet mount preparation, we need to examine all the fields under microscope. All the fields, if there is no sperm, we can say this patient is azoospermia. Azoospermia, that means no sperms. طيب هذا الازوسبيرميا إذا كان متزوج وما عنده سبيرم، في عنده أمل إنه يخلف مثلا، في last chance إنهم يستخدموا اللي هو أطفال الأنابيب. last chance if there is no sperm بيعملوا اللي هو testicular biopsy. والتستيكولار بايوبسي ان هم بروحوا على مصنع السبيرم اللي هم التستس، بياخذوا منه بايوبسي. هذا البايوبسي بياخذوها على الميكروسكوب، بيقعدوا بالبليد بيشرحوا بهاي البايوبسي وبصيروا يدوروا على سبيرم. طيب suppose that you have the wet mount preparation and you have a sperm. okay, عندك sperm. If you have a sperm under microscope, in this case you can evaluate the motility. And evaluation of motility, we have 3 categories to evaluate the motility. First one, active motile. And active motile, I mean by active motile, the sperm that across the field or that quickly across the field. And also the second category is a sluggish movement. sperm that move in their side. Also third category اللي هم dead sperm واللي هم السبيرم cannot move. And this evaluation of motility should be done in different times. When you have the sample, after complete liquefaction, you can make the wet mount preparation and you can evaluate the motility. Evaluation of motility should be percent. يعني لازم يكون عندك percentage. يعني مثلا active motile 70%, for example. Sluggish movement, for example, 20%. Dead sperm or dead percentage of dead sperm, for example, 10. Totally لازم يكون عندك 100. Okay? So you can estimate this percentage. أنا لما بطلع under microscope you can estimate, and this estimation different from person to person. For example, if I make the wet mount preparation and looking for this field, and for example I see under microscope, I estimate, and what I see under microscope, for example 70% of this sperm quickly cross the field. 20% of these sperm move in their side. 10% of sperm dead. For example, you maybe examine the same slide and estimate different. But the estimation here between me and you is plus minus. For example, if I say active motile 70%, maybe say 60 or 65%. يعني ما بكون في فرق. هو عبارة انت لما تشوف سلايد بكون زي تتكهن انت قديش نسبة الاكتيف موتايل، قديش نسبة السلجش موفمنت، قديش نسبة الديد سبيرم. فهذا التكهن بيختلف من شخص لشخص. مثلا انا زي ما حكيت ممكن اتكهن انه 70% اكتيف موتايل و20% sluggish والديد 10. ممكن انت تيجي تفحص السلايد وتقول لي مثلا والله 60% active motile 30% sluggish و10 الديد. بالنهاية لازم يكون عندي 100%. هلا evaluation of motility should be done in different times. We're looking for the percentage of active motile, sluggish movement, dead sperm. The first evaluation done after complete liquefaction. After 1 hour, we need to prepare another slide also to evaluate the motility, to know the percentage of active motile, sluggish, and dead. After 2 hours, we need to do the same things with mount and evaluate and estimate the motility, to know the percentage of active motile, the percentage of sluggish movement, to know the percentage of dead sperm. Also, I will repeat the test after 3 hours, after 6 hours, after 24 hours. So evaluation of motility should be into 3 categories: active motile, sluggish, dead. And this evaluation done in different times. Some labs evaluate the sample or evaluate the motility in different way. For example, percentage, for example, grade A, grade B, grade C, grade D. What the meaning of a grade A? Some labs, for example, record result grade A, for example, 60%, grade B 10%, and so on. Now, what the meaning of a grade A? Grade A اللي هم بكون progressive movement أو progressive motility, the sperm that cross the field very quickly. هذا اللي هو grade A. Grade B, the sperm that slow progressive can cross the field but very slow. هذا grade B. Grade C, which is the sluggish movement. Grade D, immotile or dead sperm. يعني في لابات ثانية تعمل evaluation بطريقة ثانية: grade A, grade B, grade C, grade D. grade A اللي هم اللي بيقطعوا بشكل سريع، grade B اللي بيكونوا بيقطعوا بشكل بطيء، والC اللي هم السلجش، والD اللي هم الديد. إذن هاي طريقة اللي هي evaluation للموتيليتي. Sometimes all sperm in the field not moved. يعني أنا بطلع على السلايد موجود في سبيرمز، مليان سبيرم، but هذول السبيرم not moved. In this case we need to know if this sperm is dead or not. First step, we need to add 1 drop of glucose. We need to take clean slide. I will take 1 drop of seminal fluid. Then I will take 1 drop of glucose, mixing very well and keep it for 1 or 2 minutes. Then cover it with cover slip. If this sperm start to move, that means there is no enough energy source for him to move. عشان هيك أنا بقول إنهم ما كانوا يتحركوا بسبب إنه كان عندهم نقص بالإنرجي. لما حطيت الجلوكوز بلشوا. Now, what if the sperm after the addition of glucose also not move? Now, in this case, we need to know if this sperm is dead or not. So, how can perform if the sperm is dead or not? We can take 1 drop of the seminal fluid in the center of a clean slide, and we can take 1 drop of negative stain like eosine. We can take 1 drop of 0.5% eosine and mixing very well with the drop of seminal fluid. After mixing very well, then you can cover it with the cover slip. Then after that you can examine it under the bright field microscope by using 40x أو اللي هو الهاي باور فيلد، وبشوف دائما الديد سبيرم will stand with red color because the active sperm will not stand with the eosine. If the sperm is dead, so the cell not active, so it will accept the color of eosine. So when you make the wet mount preparation by using eosine stain to know if the sperm is dead or not, any sperm stained with eosine stained with red color, we say dead sperm. If the sperm not accept the red color from eosine, we say not dead. So we need to know the percentage of dead sperm. So we need to count 100 sperm and to know from these 100 sperm how many sperm take the red color. For example, if 40 sperm stained with red color, so we can say that dead sperm here is 40%. عرفنا شلون؟ يعني أنا بعد ما حضرت الويت ماونت بريبريشن أخذت 1 drop of seminal fluid وأخذت 1 drop من ال 0.5% من الأيوزين وخلطهم مع بعضهم البعض وعملت ميكسينج، غطيتهم كفر سليب، صح؟ تحت الميكروسكوب أي سبيرم متلون الهيد تبعه باللون الريد معناته هذا ديد. اللي بيكون السبيرم مش ماخذ كلر بيكون هذا عايش. هلا أنا مهمتي إني أحدد قديش البرسنتج اوف ديد سبيرم، قديش الميتين. عشان هيك بعد أنا 100 سبيرم. من ال100 سبيرم قديش منهم هذول ماخذات اللون الأحمر؟ نفرض إنه 40 سبيرم ماخذات لون أحمر من 100، معناته البرسنتج of dead sperm is 40. Okay, so it is very important to know the percentage of dead sperm by making the wet mount preparation, by mixing the sample 1 drop of seminal fluid with 1 drop of 0.5% eosine, mixing very well, cover it with cover slip under microscope. We need to count 100 sperm from different fields. Now from these 100 sperm, how many sperm take the color red color? These sperm that taking the red color, we say dead sperm. For example, 40 out of 100 taking the red color, so the dead sperm percentage here is 40%. اوكي، هاي كثير مهمة ان اطلع قديش اللي هو البرسنتج. كمان شو ممكن اطلع انا؟ بتطلع بنحكي عنها بالسلايد الثاني المورفولوجيكال appearance of a sperm. After evaluation the motility, we need to evaluate the morphological appearance of a sperm or a morphological shape of this sperm. If this sperm, the morphological shape normal or abnormal. Let me show you the next slide. Now in this slide I will talk about the morphological appearance of a sperm. The morphology shape of a sperm or spermatozoa. You can evaluate the morphological shape by taking 1 drop of seminal fluid, mixing by 1 drop of 0.5% eosine stain, or you can make the wet mount preparation alone without stain, and you can examine after you prepare the wet mount preparation or the seminal fluid with eosine. This slide you can see it or you can use it also to evaluate the morphological shape. Now under microscope we need to look for the shape of a sperm, and you should know the morphological the normal shape of a sperm or the morphological shape of a sperm. Now the abnormality of a sperm always will be in the tail or in the head. Now you have picture, and this picture show you in the middle you have 2 sperms, one of them which is the right normal lateral view, and the second one اللي هو normal face view. إذا بالصورة الاثنين اللي بالنص هذول النورمال شيب. في عندي كمان الابنورمال شيب. الابنورمال shape, as I mentioned before, the abnormality may be in the head or maybe in the tail. For example, here we have constricted head. Constricted head اللي هو بيكون عندك الرأس مضغوط. Also in abnormal shape you can see the sperm with double tail, which is abnormal. Also you can see the sperm with double head, which is abnormal. Also we can see the head of a sperm as amorphous head or amoebic shape, also abnormal. Also we can see the sperm acute tapering form, بكون مستدق. Also we can see the sperm with large or giant head. Also you can see the sperm pinhead. All of these morphological shape is abnormal. So the normal shape, you can see it in the center of your picture. عندي صورتين أو 2 sperm في السنتر، هذا اللي هو الشكل النورمال. باقي ما تبقى اللي هو الابنورمال. Now, how can report the morphological appearance of these sperm? Now, when you have the slide, you need to count 100 sperm. And from these 100 sperm, we need to know how many sperm taking the normal shape. For example, I see 30 sperm with normal shape. So I will record normal shape 30%. Now, the abnormality should be 70% in this case. Now, with 70% of abnormal shape, we need to write the details or to divide it into categories depend on where is the abnormality. For example, 30% زي ما حكينا normal shape, so we have 70% abnormal. 70% of abnormal, for example, I have 10% with double tail. I have, for example, double head, 20%. I have amorphous head, for example, 10%. I have, for example, giant head, 2% أو 20%. معناته أنا لازم أحدد النورمال قديش والابنورمال، وأحدد الابنورمال وين صاير الابنورماليتي as percentage. اوكي طيب، هاي بالنسبة اللي هو المورفولوجيكال شيب أو المورفولوجيكال appearance للسبيرم. Now in this slide I will talk about the counting. In microscopic examination we're looking for the motility. We need to evaluate the motility. We need to evaluate the morphological shape or morphological appearance. Also we need to evaluate the counting to know the exact number of sperm present in the sample. And in counting here we need to use the diluent, which is composed of 5 gram NaHCO3 bicarbonate sodium and 1 ml of 40% formaldehyde and 100 ml of distilled water. We call this solution alkaline formaldehyde solution. This solution used to dilute the sample and to prevent their movement because it contains formaldehyde, so the sperm will not move. So when you count the sperm, we need to kill the sperm to prevent their movement, and this is done by using alkaline formaldehyde solution. So this is the diluent used. Now the dilution that used to count the sperm is 1 to 20. After you making the dilution, let the mixture stand until the mucus dissolve 1 or 2 minutes. After that you can charge the counting chamber or hemocytometer and count the square to know the sperm. Now we have 2 ways to count the sperm. For the first way, you can count the sperm in 1 square. For example, in the first YBC square you can count it. If the number of sperm is very high, you can count 1 square. You can count the YBC square, any square of YBC, or you can count the sperm that is present in the large RBC square, which is consists of 25 square of RBC. يعني أنا ممكن أعدل واحد من الأربع مربعات تبعت الوايت بي سي أو بعد مربع الار بي سي كامل. Okay. Now when you count that sperm in 1 square of chamber, you can multiply the result that you counted in this square by 200,000. بضربه ب200,000. Okay. طيب. The second way, you can count 5 square in each side. Totally we need to count 10 squares. I will go to the first side. I will count the sperm that is present in the 4 white BC squares that are present in the corner. Then I will go to the center for the RBC square, and also we need to count the sperm in this square, which is the large RBC square. So in this side I will count 5 square. I will go to the second side Also, I will count 5 square. Totally, I count the sperm in 10 squares. 8 of them for white BC and 2 for RBC square. In this case, when you count the sperm in 10 squares, we need to multiply your result by 20,000. كيف اجت 20,000 وكيف اجت 200,000؟ If you count the sperm in 100, in 1 square, we need to multiply by 200,000. And if you count the sperm in 10 squares, if you count the sperms in 10 square, in this case we need to multiply your result by 20,000. كيف اجت 200 وكيف اجت 20؟ Remember that the formula for the total cell count. Total cell count always equal to a cell counted multiplied by dilution factor multiplied by depth factor divided into number of square counted multiplied by area. إذا القانون بتتذكروا التوتال سيل كاونت شو بساوي؟ السيل كاونت اللي عديتهم انت بالمربعات ضرب الديليوشن اللي عملته ضرب الدبث فاكتور وبقسم على كم؟ على عدد المربعات اللي عديتهم مضروب بالمساحة. طيب suppose that you count the sperm in 1 square, in 1 white BC square or in the RBC square. عديت مربع واحد. In this case, the number that you count, I will multiply by dilution factor. What is the dilution factor here? 20. So 20. What is the depth factor? Because the dilution will multiply by depth factor. Depth 10. 20 multiplied by 10, so you have 200. Divided into how many square count here? I count 1 square. What is the area of this square? Is 1. So 1 by 1. So the number of sperm that counted multiplied by 200. Now 200, your result will be here per cubic millimeter. But always when you report the result for seminal fluid analysis, your result must be per ml. So how can changing the result from a cubic milliliter to 1 ml? I will multiply my result cubic milliliter by 1000 to make it by ml. اوكي معناته حتى احول الريزلت اللي بتطلع مع القانون اللي احنا بنعرفه بطلع لي بير كيوبك مليليتر. ملاحظين انتو شو اللي صار؟ انا ضربت الديليوشن 20 في الدبث 10 قديش صاروا 200. قسمت قديش عديت مربعات عديت مربع واحد. قديش مساحة المربع الواحد؟ هذا واحد. معناته صار عندك الرقم اللي عديته انت مضروب بكم؟ 200. هلا الريزلت هاي راح تطلع عندك بير كيوبك مليمتر. لازم الريزلت تطلع بير ام ال. شو بعمل انا؟ ال 200 هذول بضربهم ب 1000 لانه بدي احول الكيوبك مليليتر الى 1 ام ال، فبضرب 200 في 1000 صاروا اللي هو 200,000. صاروا 200,000. معناته انت دائما لما تعد مربع واحد شو هالرقم اللي بيطلع عندك من السبيرم بهالمربع بضربه ب 200,000 تطلع النتيجة مباشرة بير ام ال. Now when you count the sperm into 10 squares in both sides, in this case we need to multiply by the dilution, and the dilution here is 20 multiply by the depth. والdepth اللي هو كم؟ 10. معناته 20 multiplied by 10 200 divided into a number of square. How many square count? 10 squares. The area of this square is 1. شو صار عندي؟ total cell count is cell counted multiplied by 20 multiplied by 10 depth divided into 10. 10 مع 10 I will remove it. So we have here in this formula sperm count multiplied by dilution. اوكي معناته صار الرقم عندي مضروب بالديليوشن لانه الدبث راح مع عدد السكويرات اللي تحت اختصرناهم فصف عندي 20. بس هذا ال 20 اذا انا عندي السل اللي طلع عندي بال10 مربعات مضروبات بال20 بيطلع الريزلت تبعتك بير ايش؟ بير كيوبك مليليتر. النتيجة دائما لازم تكون بير ام ال. عشان هيك 20 I will multiply by 1000 1000 to make it per ml. So when you have 10 squares, the number of sperm in 10 squares I will multiply directly by 20,000. وعرفنا كيف ال 20,000 اجت. 20,000 come from dilution factor 20 sorry في depth factor 10 divided into 10. So you have 20. To make it as ml I will multiply by 1000. 20 by 1000, so the result will be 20,000. So when you count 10 squares, the number of sperm I will multiply directly by 20,000, and your result will be in this case per ml. Okay, ان شاء الله تكونوا فهمتوها. This slide show you the normal values of seminal fluid analysis, or normal of seminal fluid analysis. Normal, for example, the volume, normally you can see it between 2 up to 5 ml. The pH, normally you can see it between 7.2 up to 7.6. The count, what about the count? The sperm concentration or counting per ml, you can see it between 20 مليون up to 160 مليون، من 20 ل 160 مليون للمقل الواحد. هذا النورمال كاونت عند أي شخص. السبيرم كاونت بير ejaculation 7 مليون and 40 740 per ejaculation. How can know per ejaculation? Suppose, for example, that you have sample with 3 ml and make your count, and the counting is 5 million per ml. So 5 million per ml. So how many sperm per 3 ml? Per ml is 5 million. Per 3 ml, so I will multiply 3 ml by 5 million. So you have 15 million per ejaculation. يعني انت قديش بتعد لما تيجي كل عينة وتعمل اللي هو الكاونتينج، قديش طلع معك بير مقل؟ طلع معي عندي مثلا 5 مليون. السامبل كانت اللي استقبلتها كانت 3 ml، فبقول بير ايجاكوليشن طلعت بالمقل الواحد عندي 5 مليون، في 3 ml بيطلع اللي هو 15 مليون. هاي بنسميها بير ايجاكوليشن. ايجاكوليشن يعني لكل السامبل. الموتيليتي normally between 70 up to 90% active motile within 1 hour. When you have a fresh sample or within 1 hour, you can see the motility active motile between 70 up to 90%. This percentage will be decreased with time. For example, after 2 hours, you can see the percentage of this motility will be decreased to 60 up to 70%. 60 up to 70%. After 4 up to 7 hours, the percentage of motility will be between 50 and 60%. After 10 up to 24 hours, the percentage of motility will be decreased more and more and will be between 25 up to 35. معناته لما تكون العينة فريش نورمالي لازم اشوفها انا بين 70 ل 90% الاكتيف موتايل. مع التايم شو بصير باللي هو الاكتيفيتي او الموتيليتي؟ بصير هالديكريز. بعد ساعتين بصير الاكتيف موتايل نورمالي between 60 up to 70. بعد الاربع لسبع ساعات بكون بين ال 50 وال 60%. بين ال 10 لل 24 ساعة بصير اللي هو الاكتيف موتايل between 25 up to 35. What about the morphological shape? The sperm that appears with normal shape, normally between 79 up to 90%. هذا اللي بنسميه النورمال فورم. إذا المورفولوجيكال appearance 90 أو 79 up to 90%. هذا بنسميه اللي هي النورمال فورم. نورمال فورم من المورفولوجيكال شيب between 79 up to 90%. اوكي يا جماعه بكون كمان في يمكن انا مش حاط لكم اياه هون بس موجوده عندكم بالسلايد اللي هي البرسنتج او النورمال فاليو للوايت بي سي.
الوايت بي سي دائما عادة بتكون less than 1 مليون less than 1 مليون بير ام ال، يعني من الطبيعة اشوف الوايت بي سي بس تكون باعداد قليلة. هاي بالنسبة للنورمال فاليوز اللي ممكن اشوفها للسيمينال فلويد اناليسيس. مرة ثانية الفوليوم 2 up to 5 ml be at 7.2 up to 7.6. The sperm concentration per ml 20 up to 160 million. The sperm count per ejaculation 740 million. The motility in a first sample within 1 hour 70 up to 90%. The morphological shape normally or normal form between 79 up to 90%. And the motility, as I mentioned before, will be decreased with the time. هذا كل شيء بهذا السلايد ممكن أحكيه.
Now this slide show you the report, how can report the seminal fluid analysis. You can see here in the report, for lab use only, we need to fill all the area here in this part. For example, period of abstinence. The period of abstinence, now if you have patient in your lab, after you taking the sample, you need to ask the patient about this period of abstinence and record it in the container and in the request form. So the period of abstinence should not be less than 3 days and not more than 7 days. The method of collection, the most common method used اللي هي master patient by using the hand. The volume normally between 2 up to 5 ml. Okay, check the volume of the sample you have in the lab and record the volume. The appearance whitish, creamy, depending on the color, you can report it in the report. The consistency, viscous, mucus, liquid، شو انت شايف بتسجلها. Liquefaction was completed at liquefaction time. Very important to know the time that taken to changing from gel to liquid. Okay, التايم قديش اخذت تايم حتى تحولت من جل لليكويد، هذا liquefaction time. The sperm count per ml after you count in the chamber. Okay, how many millions per ml بسجل. الوايت بي سي RBC. If you have white BC and RBC in the sample, you need to count the white BC in the 4 squares of white BC. If you have RBC, you need to count the RBC, the 5 square of RBC, the 5 small squares of RBC squares. We need to write it. Okay. Also, here we have the morphological shape. Well, morphological shape or morphological appearance, we need to count 100 sperm, and from these 100 sperm, how many sperm present as normal, percentage of normal, and we need also to record the abnormality. Where is the abnormality? Pinhead, roundhead, and so on. لازم أسجل percentage for the abnormality shape. Also here we have a part for motility study. As you see, we need to evaluate the motility into different times, after 30 minutes, after 3 hours, after 6 hours, and after 24 hours. And your evaluation should be as the percentage of active motile, and the percentage of a sluggish movement, and the percentage of immotile or dead sperm. For example, after 30 minutes, if I have 70% motile, so I have 20% for sluggish and 10% for immotile. معناته لازم انت تعمل evaluation للmotility بأوقات مختلفة. Then after that you can check the fructose, and normally fructose between 50 up to 500 milligram per deciliter. If there is any additional comment, you can write it. You can write it the date, and you can make your signature in the report, and the report here is ready. هذا اللي هو كيف احنا نكتب الريبورت. كثير بسيط، بس نخلص ونوقعه ومنسلمه
إذا في عندك اللي هو التراكنج سيستم بدخله على السيستم وبسلمه اللي هو البيشنت صاحبه.
Here in this slide I will talk about the macular counting chamber. And macular counting chamber mainly used in IVF unit في وحدة أطفال الأنابيب. As you see in the picture, this macular counting chamber composed of the chamber and it is covered. This chamber under microscope divided into 100 squares. The length of each square and the width is equal. Length 0.01, width 0.01, the same because it's square. So the number of squares under microscope 100 squares. Normally we need to count 10 squares. And the number of sperm in 10 squares will be in million per ml. يعني شو بيطلع معك من سبيرم في 10 مربعات بكون العدد هذا بالملايين per ml. For example, if you count 10 sperm in the 10 squares, that means you have 10 million. If you have, for example, 6 sperm in 10 squares, that means you have 6 million. If you have, for example, if you count, for example, 10 squares and 10 sperm in 10 squares, that means you have 10 millions per ml. If you count, for example, 20 sperm in 10 squares, that means you have 20 million per ml. Always the counting will be done by using a special lens or special objective lens 20x. And our microscope in our lab, we have the objective lens low power 10x, and we have also 40x. But in IVF unit, وحدة الأطفال الأنابيب, there is a special microscope containing objective lens with 20x. And mainly we need to use 20x. Then under 20x lens, you can see the chamber divided into 100. What we need here to count the sperm in 10 squares, and the number of sperm in 10 squares will be in million per ml. زي ما حكينا إذا عديت 10 مربعات ولقيت فيهم 10 سبير معناته 10 مليون. إذا عديت 10 مربعات ولقيت فيهم 16 سبير معناته 16 مليون. إذا عديت لقيت مثلا 20 سبير, that means 20 million. Okay, normally we need to count the sperm in 10 squares. But sometimes if the number of sperm that you have under microscope is very low, to make your result accurate, more accurate, we need to count 100 squares. إذا لما يكون عندك رقم السبرم تحت الميكروسكوب شايفه كثير قليل, في هالحالة بنفعش عد 10 squares, we need to count 100 square. And the number of 100 square here, I will divide it into 10 squares. Then your number will be in million per ml. خلينا نشوف يعني. For example, if I have low number, I need to count the sperm in 100 squares. Suppose that you have 50 sperm in 100 squares. Normally we need to count 10 squares, not 100. But here, because we have low number of sperm, I count 100 square. And suppose that you have in 100 square 50 sperm. In this case, 50 sperm, I will divide it into 10, and your number will be in million per ml. 50 divided into 10 قديش تطلع؟ 5. That means 5 million per ml. For example, if you count sperm in 100, for example, 90 sperm in 100. 90 divided into 10, 9. That means 9 million per ml. This in case of you have low number. Sometimes you have high number of sperm. And in this case, because the number is very high, you can count any square present in the chamber. Any square. And the number of sperm that present in this square, I will multiply by 10, and your number in this case will be in million per ml. Suppose that, for example, I count the sperm in in 1 square and you have, for example, 10 sperm. 10 sperm in 1 square. In this case, 10 sperm I will multiply by 10. So 10 by 10, so you have 100. 100 مليون بير ال. إذا لما يكون عندك الرقم من السبيرم كثير عالي بعد مربع واحد، قديش بيطلع معه من السبيرم بهذا المربع بضربهم ب10 بكون الرقم عندك المليون بير ال. For example, if you count, for example, 7 sperm in 1 square. In this case, 7 multiplied by 10, so you have 70 million بير ال. هاي كيف إني أعمل counting على الماكلر counting chamber. As I mentioned before, there is no need to make the dilution for macular counting chamber. So this is the only chamber you can use it without dilution. No need to make the dilution for macular counting chamber. ويعطيكم العافية. والأسبوع القادم إن شاء الله راح نحكي عن، أو الجزء الثاني اليوم راح نحكي عن الساينوفيال فلويد. بنكون هيك خلصنا المساق. كنا على أمل إن نلتقي باللاب، بس انتم شايفين حالات الكورونا في ازدياد والوضع صار أصعب.